Hello, this is Kuku and I'm here to teach you about an important algorithm in natural language processing. Have you ever wondered how an NLP model is being able to process the basic language that we humans use to communicate with each other? Because all these years we have been breaking our head trying to learn codes to make machines understand what we try to say it. Now it has been taking the English language and understanding our commands and literally do what we say. For example, we can take the most popular one, the ChatGPT, because it is basically understanding the command that we give in basic English and process it and provide the output that we ask it. So how does it do that? It's been a lot of research done in this field, and people came up with different algorithm to feed into machines so that they can process this language, because what we speak has a lot of contextual meaning, lot of hidden details between those words. So let's get started with understanding a most basic algorithm that is done to break down words to the machines. That is known as Porter-Stemmer algorithm. Before starting, let's just break down this word stemming, and understand what it is. So what is stemming? Stemming, it is basically cutting down different forms of the same word so that we are ending up with the same word. Like you have a slice of bread and you cut the edges, right? So similarly, we are going to cut the edges of different forms of word. I have given an example here, like, likes, likely, liked, and liking. Both has a root word as like. So how do we do that? Be it affix, suffix, or prefix, we are going to cut it down to get the same root word. So for cutting down a word, different people may end up in different answer, because let me take an example of this word stemming, and I'm really interested in cutting down this ing, so I'll get up the word STEMM, and my friend here is being smart. He figured out that STM is the root and he's going to cut down stemming, MMING, and he'll end up with the word stem. So we are having two answers to the same words. And what we are doing here, it should be universal, right? So everyone should end up in the same answer. So for doing such a process and getting the same result, there should be a steps of rule in a form of an algorithm that should be followed. And that is what we are going to see here today. That is known as Porter-Stemmer algorithm. Let's jump deep to the algorithm. Okay, before starting the algorithm, there are some few basic concepts that you should be familiar with. It's called vowels and consonant. Everyone knew that A, E, I, O, U is vowels and rest of it is consonant. Now let's look into the term M. Term M is the measure of words. In detail, before understanding M, let us understand the CV denotation of a word. What is CV? It's simple. C stands for consonants and V stands for vowel. So if I take an example of word mom, M is a consonant, so C. O is a vowel, so V. Similarly, M is a consonant, so C. So let's do for some other words and decode it in the CV notation. Tree, we have tree. It is a C, C, V, V. E is a vowel, and similarly for fan, C, V, C. So we got this CV notation that is needed for Porter-Stemmer algorithm. You can try it for that. Okay. Let's see what is M. So what is M? M is a measure of word. And in the previous example, we have seen the CV notations, right? It is about counting the number of CV notation. Here, CV occurs once. And in high, CV occurs one. So similarly, if let's see CV is equal to 0 words, like let me my, I can take example as my, and by, because it will be CC, so there is no CV notations. And similarly, trouble won't come here. Trouble has M is equal to 2. So oats, we can take oats. Oats has CV, CC. So there is one CV occurrences, and here are few other examples. Let's try out for troubles. Troubles is CCVV, CCVC. We can count the number of CV occurrences. Here it is occurring 1, it is VC, so we just avoid it, and here it is once, so we are getting 2. So here are other few M is equal to 2 words. You can write out and check. So we are familiar with the concepts of M. Now I will give an introduction to the rules that we have been talking about in this algorithm. This is the basic standard form of the rules that we are going to see. S1 is the word and S2 is our output word. So for S1 to become S2, a condition should be satisfied. And this condition is a long list. I'll be showing you a few minutes later. And that condition should be referred upon to the list of rules so that we can transfer this word to this word. This is our output word S2. Okay, let's just move on. And before understanding the condition, there are few notation that should be we are familiar with. And here star S means capital letter S. You have to note that if a word is given as star and its capital letter form, it means that the word has been ended with this S. Okay, so if it is balls, BALLS, it is star S. Okay, and if it is star star and V, it means that the word contains vowel. That is star means anything else, and we have V here, so it contains a vowel in small letter. It is case sensitive. Okay, M is equal to 2. I've given example of words which has M is equal to 2 here. So that is what we given here. And star D in small letter, star D means it's not the word is ending with D. It means that if it is in small letter, it means that it has double consonant. Double consonant is in TT, SS, okay, RSS, all those words can be given as an example. And star O means CVC notation. We have seen CV notation. There is another notation on a CVC notation, and it is denoted by star O. And a condition is that the word should not end with WXY. So that's the foundation for POTUS-HTML. Let's move on to the algorithm. What is the rules of POTUS-HTML algorithm that I've been talking about? So it is really lengthy. We have 1, 2, 3, 4, 5, 6 steps, and this is a step that should be followed in this order only. And each step is being addressed by its name. The 1A step means that whatever, there is no condition here. I've said earlier that there will be a condition and sentence 1 will become sentence 2. Here there is no condition. Blindly, first of all, if you get a set of sentence and you see SSESS, it becomes SS. IES becomes I. SS becomes SS. Okay, S becomes nothing. So S, if it is there, just ignore, just cut it down. So cats become cat, and caresses become cares, and ponies like become pony. Ties become tie. So it won't here ties become tie. You might wonder it doesn't mean anything, but the rule is to cut it down, so we just cut it down. Similarly, 1B step, we got a condition here. If M is greater than 0, that is, it should be having at least one CV occurrence, and we have EEED in that sentence. Just remove that D. Like feed, here we have a CV occurrence, like ED is a CV occurrence, so M is greater than 0, and we have an EED. So what do? We just remove, I have made an error here, remove that T. Okay, EE. Similarly, agreed becomes agree. And verb B, what does B stands? B here is that there is an occurrence of vowel in this sentence. So what do? If there is a vowel, just cut down the ed. Don't talk about the past tense. Ed stands for past. So if there is a vowel in that sentence, remove that ed. Cut it down. Simple as that. And ing, cut it down. If there is a vowel in that sentence, as we talked about earlier, this notations means a lot. So we don't need to write if there is a vowel. Just mention star, be star, and ing. If you see an ing, cut it down. It becomes nothing. Cut it down. And S goes nothing, no condition, no matter whatever the sentence be. If you see an S at the end of the sentence, you just cut it down. For example, in this rules, nothing. If you see that S, cut it down. That's the rule. And similarly, for the second and third rule, if it is successful, you can blindly follow these steps. Like AT becomes ATE, BL becomes BLE, IZ becomes IZE. So I have given the examples here. These are like the steps that we have to look into it repeatedly, so that it becomes natural to you. Like cutting down S, cutting down E, D. Okay, and in paper they might ask you to give the rule number also. That is a bit difficult to remember, but at least you should be able to tell what to cut down naturally. Like it becomes obvious to us. You see S, S, E, yes, cut it down, cut it down. So that should be the attitude that you'll be having while attempting this question. Okay, and let's move on to the rule number 1C. And I'm not explaining here these things, because it becomes, we are just cutting it down. S becomes nothing, IZ becomes IZE. So similarly, let's just move on to 1C. If there is a vowel in a sentence, Y becomes I, that is happy becomes I. Here it is Y. Earlier we talked about S. If we see S, just cut it down, but if you see Y, just make it I. Okay, and it deals with the plural and past participle. The step 1 deals with the plural and past participles. Yes, of course, because S, ED, and ING, EED proceeds, all those words will be turned into ED. So it deals with the plurals and past participle. Let's move on to step number 2. Here we have a condition. M is greater than 0. So first of all, if we get a sentence, just calculate the M value. So if it is greater than 0, you are getting into a lot of conditions here, because all those words should be transferred to these words. Okay. It should be learned like this only. You can see, just if M is greater than 0, you just cut down all these conditions if it is satisfied. Okay, next let's move on to the rule number, the step 3. It is also similar to step true only. If is m is greater than 0, these words will become these words. Okay. And similarly, you rule number 4, if it is greater than 1, you have all those conditions. And fifth condition, this is self-explanatory. Okay, m is greater than 0 means you have to cut down the last part which resembles this. I see able, ible, ant, ent, and ment, all those things becomes nothing. Okay, so it's really hard to remember, but in real world application we have a library which everything is being feeded to it. So I'll talk about it at the end of the video as an extra. And step number 5, we have m is greater than 1 means e becomes nothing, and m is equal to 0 and not. I think you're familiar. If you're familiar with the logic gates, all those things, if you're done earlier, you'll be knowing what is and not. And means both conditions should be satisfied, and not means the opposite. So star o, if a word ends with o, not o means other words which does not have o at its end, and m is equal to 0, it means e becomes nothing. Like cease becomes, it's not o, e is not o, right? So e becomes nothing, so we just cut down the e. And this final step b, m is greater than 1 and star d and star l. Star d means, what did I say earlier? It is a double occurrence of a consonant, that is ll. And star l, it ends with the word l. Control ends with the word l. And m is greater than 0, it becomes a single word, that is control becomes control. Okay, roll becomes roll. I just made an error here, we just remove that. Okay, so these are the set of rules of autostomach algorithm. Let's see the real world application. How do we do that? In exam, you can do it by hand. You can just mention the rules. And so how we are going to perform post-stem algorithm, because in real world the data will be in tons, and we won't be able to process by hand and keep on referring that big rules list. So we have a library in Python that is in NLTK, which is a famous library for NLP. You can import PorterStemma and assign it to PS. And if you give the words like this, I've given taken Python itself as a word: Python, Pythonaire, Pythoning, Pythoned, and Pythonly. Okay, it's looks like it is the stem word or will be Python, but let's see what is happening. If I run this, I'll be getting Python is Python, Pythoner is Pythoning, and Pythoning is Python. That is, we seen in the rule 1a that ing, ed, er will all be removed. And in second rule, we have seen that y will become I. So that's what happened here. Pythonly alone will become Python li. Okay, I'll just show you what is inside this library, because we have learned so much rules. They are literally feeding all this is the code that I've pasted here for that. What is inside this library I've pasted here. Let's see. It has everything, like all the rules have been given as a function: 5a, 5b, 4, 3, everything is there as a function. Even it is checking whether to replace or the CVC notations, or it has double consonant, that is chardy, contains vowel. Everything is being given as a function here. Our only duty is to call it and use it. So we don't have to remember this words in real life. We have functions for that, but in exam we should be able to decode it by hand, because that word will be the question will be in a sentence. So that is it about post stem algorithm. I hope it is clear for you. Thank you.